Good morning, guys. I hope you're having a blessed spring break. And today I was going to show you a brief little demonstration on the mechanism of caffeine. Mechanism, of course, means how this substance or drug works in our bodies, all right? First and foremost, though, since I'm out here in the hall in front of my room in my lab, I was going to show you just some of the little things that guys have made over the years. I'm proud of this stuff, you know? And of course, on the bottom row there, you see some of the fossils I have. And then over here, let me zoom you around for just a second. In this display case, we have a bunch of lab items that are antiques, really. These are antiques. Some of these are older. Actually, all of these are older than the building itself. And then next to that, I have a whole row there of primate fossils, including like gorillas and arrowheads from Camp Tekoboka. And then over here I have some seashells all the way from Australia. Brother Dave Quigley gave those to me, so those are pretty cool. All right, but back to this doorknob here, and of course the mechanism of caffeine. So in biology, when you get to cell membranes, we talk a lot about this whole key and lock kind of idea. It's an image or an analogy that gets used a lot. How do things enter a cell through that cell membrane, right? Like whether it's a hormone or whatnot, how do they get into the cell and what is their job, right? So in this example, we're going to talk specifically about neurons. Okay, so when neurons are activated, you have all sorts of electricity, these impulses that get carried across that axon, right? Because the axon is covered with myelin. And myelin's kind of a fatty substance, which is very, very efficient at carrying electrical impulses. But when this impulse gets all the way to the end of the axon, you have something called an axon terminal. And when you get to the end of the axon terminal, now you have this synapse. And that's what this is trying to represent. This is a synapse right here, okay, fellas? So if you can kind of make believe that I am a presynaptic axon terminal, in this area here from me to the door, this is the synapse, or the space between neurons, okay? And this doorknob itself is going to be the postsynaptic dendrite, okay? And of course we have some sort of reaction that's going to take place when this key is going to fit, okay, into that doorknob. So again, that's an image or an analogy that we talk about a lot throughout the year in biology, and also a little bit in psychology, okay? So check this out, guys. In this synapse, there is a neurotransmitter, a chemical called adenosine. And adenosine is constantly going across, like so, right? There we go, there we go. It goes across, and it's kind of a chill out neurotransmitter. It is responsible for making you relaxed and even a little bit sleepy, okay? So you got this adenosine going across, bam, there you go, right? And it's doing its job. And when this postsynaptic dendrite is activated, it causes this reaction to occur in the next neuron, and then the next neuron, and so forth and so on. So you might recall that neurons act a little bit like domino effects, which in other words, once one is activated, the next one gets activated, and so forth and so on, okay? With that said, there's the, one more time, I'm kind of multitasking, holding a phone, doing this, but there you go. All right, that's adenosine, all right? So you get up in the morning and you have that cup of coffee. So now you have this caffeine that's going across the synapse, okay? So this tape that I'm holding represents, of course, the caffeine. And it goes across, and the mechanism of caffeine is that it blocks these specific receptor sites for adenosine. So now when adenosine is trying to get across, it can't get through, okay? And if it can't get through, it can't do its job. So yes, caffeine, fellas, is a stimulant. It is an upper, okay? It's in the same kind of mindset of drugs that like nicotine and many, many others that are like way worse and illegal, like cocaine and meth and so forth and so on, okay? But this is how caffeine works. It's an upper, it is a stimulant, but it stimulates us by blocking or slowing down this port of contact for another neurotransmitter entirely. So to kind of wrap up the last few thoughts here, caffeine, gentlemen, is an antagonist. So antagonists are substances, it could be drugs or other neurotransmitters that block other neurotransmitters. So in this case, caffeine is blocking adenosine, okay? But then you have other things that are entirely different that are called agonist. So you might think of some of those, like if you've seen the antidepressant commercials for like Prozac and Zoloft and whatnot, they are actually mimicking the effectiveness and the efficiency of things like serotonin. So now you have more serotonin type substances going across. So in that sense, you would say that many of your antidepressants are agonist. So caffeine is a stimulant, but it is an antagonist because it blocks, right? See, one last time, it's blocking my adenosine, in this case, which is played by my key. All right, guys, I hope you're having a great spring break. I'm here on campus today feeding my, my critters and watering the plants. I look forward to seeing you boys on Monday. So peace out and God bless.